So good morning. In this video, we are going to see about study of logic gates. This is the first experiment of digital electronics lab, right? So, here we are going to see the pin details and truth table of each and every gates, right? So first of all is the AND gate. So this is the symbol of AND gate, two input AND gate, A and B, and output will be F equal to A dot B. So here this dot indicates AND symbol. Dot will be the AND symbol. This is the pin details of AND gate 7408. Okay. So here the 7408 will be 14 pin IC. It's a dual IC, right? 14 input IC. It starts from here wherever the notch or dot will be appear on the IC, front panel of the IC. Nearer to that, we have to start pin number 1, 2, 3, 4, 5, 6, 7, and 8th pin will be starts from here, right? 8, 9, 10, 11, 12, 13, and 14, right? So here 7th pin and 14th pin will be ground and VCC respectively, right? So here in IC 7408, 4 gates will be there. 4 gates, 4 and the gate will be there. Pin number 1 and 2 will be input of first gate, 3 will be the output of first gate, and 4 and 5 will be the input of second gate, 6 will be the output of second gate, and 9 and 10 is input of third gate, right? 8 will be the output, 13 and 12 will be the input of fourth gate, and 11 will be the output, right? So this is the pin diagram for 7408. Okay. So truth table, when we come to the truth table, the AND gate is similar to the multiplication. AND gate similar to the multiplication. Here two inputs A, B, two inputs and output will be A and B. We have to read A and B, right? So if you are giving 0, 0, my output will be 0. And if it is 0, 1, my output is 0. So 1, 0, my output is 0. And 1 and 1, my output is 1, right? So this is similar to multiplication. If either input is 0, my output is 0. Both the inputs are 1, then only I will get 1, right? So this is a AND gate. And for OR gate, here also the same thing, A and B, right? Two inputs and output will be A or B. We have to read like this, A or B. Okay. So here the pin details the same like as 7408 AND gate. So here the IC number will be 7432. 7432. The same thing. 7th pin and 14th pin will be the ground and VCC respectively. Here also we are having 4 gates inside, 4 OR gate inside 7432. Here the truth table 0 and 0, right? 0 and 0, my output will be 0. 0 or 1, right? We have to read as 0 or 1. My output is 1. 1 or 0, my output is 1. 1 or 1, my output is 1. All right. So this is similar to addition. Here you have to get confused, right? 1 plus 1 will be 2, right? 1 plus 1 will be 2, right? So here in decimal, but here in a binary you will get 1 plus 1 will be 1. Okay. So if either input is 1, I will get 1, right? Either any one input is 1, I will get output will be 1. This is about OR gate. And come to the NOT gate, it's only one input, one output. So if you give A, your output will be A bar, or we call it as A complement. If it is 0, your output is 1. If it is 1, your output is 0. So come to the pin diagram. So IC number will be IC 7404, right? 7404, and here we are having 6 gates. Inside 7404 we are having 6 NOT gate. This is a symbol for NOT gate, right? So this bubble is a inverter, so indicate it's an inverter bubble. Okay, so come to the truth table. It's only one input, one output. If you give 0 input, my output will be 1. If your input is 1, my output will be 0. So not gate, or we call it as an inverter. Simply we call it as inverter. And here it is a 3 input AND gate. So in previous we discussed 2 input AND gate. Here this is a 3 input. 3 input AND gate, A, B, C. My inputs will be A, B, C, and output A and B and C. A and B and C. And come to the pin diagram, its number will be IC7411. IC7411. Here we are having only 3 gates, 3 AND gate, 3 input AND gate inside the 7411. Here the input for first gate is pin number 1, pin number 2, and pin number 13. Pin number 13, my output will be pin number 12, right? And for second gate, my inputs are 3, 4, 5, and output is 6. And for third gate, my inputs are 11, 10, and 9. My output is 8. So only 3 gates will be there inside 7411. So come to the truth table. So the truth table will be A, B, C, right? A, B, C or the input. So if it is 0, 0, 0, my input is 0. So 0, 0, 1, my output is 0. 0, 1, 0 is output is 0. So the theme of the truth table will be if any input is 0. If any input is 0, my output will be 0. Any input is 0, my output will be 0. And if all the input is 1, then my output is 1. Okay, so this is the truth table for 3 input AND gate. And 3 input NAND gate. This is 3 input NAND gate. So here, what is a NAND gate? It is a combination of AND plus NOT gate, right? AND plus NOT gate. This represent AND gate and this represent NOT gate, right? So this structure is a symbol is NAND gate. Okay, so 3 input A, B, C, and output will be A and B and C bar, right? A and B and C bar. Okay, so here the pin details the same like as 3 input AND gate, right? The pin IC number will be IC7410. So for a first gate 1 to 13, 12 will be the output. For second gate 3, 4, 5 will be input and 6 will be the output. For a third gate 9, 10, 11 will be the input, 8 will be the output, and ground and VCC will be 7 and 14 respectively. Okay, so for here the truth table, if you come to the truth table, it's a 3 input, and output will be A dot B dot C bar NAND gate, right? So 0, 0, 0, my output will be 1. So 0, 0, 1, my output will be 1, right? So in AND gate, if it is a 0, either input is any one input is 0, my output is 0, right? So here just complement of AND gate. So wherever 0 we got, that is a 1, and wherever 1 is there, that is 0. If 3 input is 1, my output will be 0. This is 3 input NAND gate. Okay, so 2 input NAND gate, the same thing, 2 input NAND gate. This is the 2 input AB and A dot B complement, that is AND complement, and the complement AND plus NOT. This symbol, circle symbol, indicates inverter. This is a combination of AND gate and inverter. Here we are having 4 gates, right? Inside IC7400 is the number for 2 input NAND gate. And the truth table, it's a 2 input. Output will be A dot B bar, right? So 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. My output will be 0. This is a truth table for two input NAND gate. Okay, so here we will see only three ICs, how to connect it and how to take a reading, how to verify the truth table using trainer kit. First we will see, and 1 minute. So, good morning, students. In digital electronics lab, we are going to do some experiments, right? Today we are going to do about study and implementation of logic gates, right? So, in this experiment, there are various types of logic gates will be there. In that, first we will discuss AND gate, right? So, we are going to verify the truth table of AND gate using trainer gate. Okay. So this is the pin details of AND gate. AND gate IC number will be IC7408. Right here, there will be a 14 pin ICs. There will be 14 pin ICs will be there, right? So each side we are having 7 pins, right? So starts from here, right? 1, 2, 3, 4, 5, 6, 7, right? So here the 7th pin will be ground, and the 8th pin will starts from here, 8, 9, 10, 11, 12, 13, and 14, right? So again the 14th pin is a VCC, right? So to operate this IC, 14th pin and 7th pin will be very, very important. The connection, we have to be careful. We have to give the connection VCC to 14th pin and ground to 7th pin. Okay. So in 7408 IC, we are having 4 AND gates. 4 AND gates. So for the first AND gate, 1 and 2, these two pins are act as a input of first AND gate, and 3 will be the output of first AND gate, and 4th pin and 5th pin will be the input of second AND gate. Pin number 6 will be the output of second AND gate, and for a third AND gate, 10th pin and 9th pin will act as an input for third AND gate, and 8 will be the output, and 12 and 13 will be the input for fourth AND gate, and 11 will be the output, right? So this is the symbol for AND gate. So inputs, 2 input AND gate, right? So here the inputs are A and B. My output will be, it is a multiplication factor, right? It is a multiplication property AND gate. So A dot B, we say as A dot B, or we can say as A and B, right? So this is the truth table. A and B will be the input, and F will be the output, right? So here, because of two inputs, there will be 4 possible conditions, right? 0, 0, 0, 1, 1, 0, and 1, 1. Okay. So if you are giving 0, 0 as input, your output will be 0. If it is a 0 and 1, your output will be 0. If your input will be 1 and 0, your output will be 0. If your input is 1 and 1, your output will be 1. Right? See this truth table. If both the inputs are positive or both the inputs are 1, then only I will get output 1. Okay. So this is the truth table. This truth table we are going to verify using the trainer kit. This is the trainer kit. Here this is 7408 IC, right? This is 7408 IC, AND gate IC, which is having 4 AND gates, right? These are all input section. This is output section. This is power supply section. These 3 sections we are going to use to verify the truth table of AND gate. Okay. So here I require 2 inputs, right? So this is one input. I connected from input side, and one more input, right? Output I will connect somewhere here,
output section, and we have to give plus 5 volts and ground, right? This is required for operating the IC. Okay, so and we are going to check first gate, right? So for the first gate, 1 and 2 will be the input and 3 will be the output, right? So where is first pin? This is my first pin, right? I connecting 1 and sorry, first pin will be my first pin. Second pin connecting here is the second pin, right? And the output will be from pin number 3. I am taking from pin number 3, right? This is my VCC plus 5 volts. VCC we have to connect it in pin number 14, and the ground wire we have to connect it in pin number 7, right? So now connections are over, right? So I connected first pin and second pin as a input, and the output pin will be connected in the output section, right? So I given a power supply plus VCC and ground to the pin number 14 and pin number 7 respectively, right? So now we are going to check the truth table for the possible 4 conditions, that is 0, 0, 0, 1, 1, 0 and 1, 1. So now I switched on the trainer kit. So now the input will be 0 and 0. My output is 0, right? My output is 0. If my input is 0, 1, again my output is 0. My input is 1, 0. My output is 0. If my input is 1 and 1, my output is 1, right? So again 0, 0, 0, 0, 1, again 0, 1, 0, it is 0, and 1 and 1, my output will be 1, right? So this is the first gate. So now we verify the truth table for first gate, right? So now we are going to check for second gate, right? So for second gate, 4 and 5 will be the input and 6 will be the output. So for checking the second AND gate in 7408 IC, I am not disturbing the connection of VCC and the ground. Leave it as it is. Now you are giving input to pin number 4, right, and pin number 5. Okay. My output connection, give it to pin number 6, right? Now the connection over. Now we are going to verify the truth table for second AND gate. Okay, see here, switching on the trainer kit, right? So now it's a 0, 0, my output is 0, 0, 1, again my output is 0, 1, 0, my output is 0, and 1 and 1, my output is 1, right? So now we verified the truth table of second AND gate, right? So likewise you can verify the third AND gate and fourth AND gate of the truth table. Okay, so for a third one you have to give 9 and 10 as an input, 8 as an output, right? And for fourth one, 12 and 13 will be the AND gate and AND gate input, and 11 will be the output of the fourth AND gate. So likewise for all the AND gates you have to verify the truth table of AND gate, right? So this is the truth table. This is a multiplication table, right? This is a multiplication, this one. If any input is 0, I will get 0. If any input of AND gate is 0, my output will be 0. So when I will get output as 1, if my input, all the inputs, right? So there will be a 2 input AND gate will be there, 3 input AND gate will be there, right? So if all the input is 1, then only I will get output. Okay.
on the laboratory experiments. So we have 10 experiments. So under that, the first experiment will be based on study of logic gates. So we already know. So in a logic gates, we have various categories like AND gate, OR gate, NOT, NAND, NOR, XOR, like that. So from that, so in this laboratory, so we are going to see so what is a NOT gate. So this is one of the gate in a logic gate. So for experimenting, so we are using a digital IC trainer kit. So in this digital IC trainer kit, we are using some breadboards. So for making the connections. Then apart from that, so it contains some input ports. Then it contains some output ports. Then after that, we are applying some voltage level, that is 5 volts, to be given to this IC. Okay. So first will be based on NOT gate. So NOT is nothing but, so it is an inverter circuit, or it will be called as an inverter. So we are giving the input as 1 means the output will be 0. Then the input will be 0 means so the output will be 1. So depending upon the pin diagram, so here, so the IC contains 14 pins. So out of 14 pins, one pin will be considered as a ground, then another pin will be considered as an VCC, that is based on the power supply. Then apart from that, so remaining 12 pins will be act as either input pin or output pins. So in an inverter IC, so the first pin will be act as an input means the second will be an output. So likewise for third will be act as an input means the fourth will be an output. Then fifth will be an input means sixth one will be an output. Then the ninth pin will be act as an input. Then eighth will be an output. So then 11th pin will be an input. Then 10th will be an output. And 13th pin will be an input. And 12th will be an output. So based on the truth table representations, once we are giving the input as 0 means the output will be inversion of that input value, that is 1. Then input as 1 means the output will be 0. So based on the Boolean expression, it can be represented as so output equals inversion of an input, that is F. We are applying input as A means the output will be F equals A bar. So F will be considered as an output category. So now, so we will see so how the circuit connections will be so performed by using digital IC trainer kit. So I'm placing IC, that is IC number 7404. So this IC will be called as an so not IC or inverter IC. So initially we are placing some IC. Then after that, so we want to give some power supply for this IC. So I'm giving some connections based on plus 5 volts. So this 5 volts will be given to the 14th pin of an IC. So first initially I connected some power supply connections with 14th pin. Then after that, so some grounding operations be given. So the grounding will be connected with 7th pin of an IC. Then after that, so we want to apply some input, then we want to get an output. So for input, I'm using this connections. So this line will be allotted for an input lines. So here I'm making connections between, so this with pin number 1. Then, so based on the IC representation, so second pin will be act as an output. So I am connecting second pin with the output lines. Okay, so these are the connections. So we given in this digital IC trainer kit. So I'm switching on this kit. So initially we applied the input as 0. So for the input 0, we are getting the output as 1. So that is for the input 0, we are getting output as 1. Then I'm making this input as 1 means the output gets 0. So these are the some operations performing by using this type of IC. That is inverter IC or not IC.
So thank you guys. So this video we seeing the operation and how to verify the AND gate and the NOT gate, right? So some other gates likewise the same method we can verify using IC trainer gate, right? So in the next session we will see with one more new experiment. Okay, thank you.